Hey y'all, let's practice writing some linear equations. Now when you're writing a linear equation, one thing that you'll need a lot of the time is the slope, right? How steep our line is going to be. Is it positive or negative? Is it basically vertical? Is it pretty flat? That's what the slope will tell us. So we have this formula for slope where we have the change in y over the change in x. So we're going to take our y values and subtract them, take our x values and subtract them, and divide. Now we have to be very particular for the order in which we are subtracting these x and y values. Whichever point you take the first y value from, that has to be the exact same point that you take your first x value from. It doesn't matter which point is x1 and y1, which point is x2 and y2, as long as you're consistent about which point you're starting with in this formula. I'm going to call the first one x1, y1, and the second one x2, y2. There's no particular reason for that. You could switch them if you want to. You could call this x2, y2, and x1, y1. It does not make a difference. So when we're finding our slope, we say y2, so here our y2 is -4, minus y1, which is 12, over x2, which is -2, minus x1, which is -4. But remember, when we're subtracting a negative, that's the same thing as adding that number. So now on top we have -4 minus 12, which is -16, over -2 minus -4, which is -2 plus 4, which is 2. And then -16 over 2 is -8. This is a different form of a linear equation called point-slope form. And it's called that because in the formula itself, we have a point, x1 and y1, and we have a slope, hence the name point-slope. So in this example, we're going to write the equation of a line through this point, 2, 3, with a slope of 1/2. And we're going to write that equation using point-slope form. When we're writing this equation, we're going to keep this first y in our answer, we're going to keep this first x in our answer, but everything else is going to have a value. So this point, this is our x1, y1, the slope is our m, and that's what we're going to substitute into this formula. So we've got y minus our y1 is 3 equals the slope. Then we put our parentheses and we put x minus 2. Since we're just putting this in point-slope form, there's nothing we need to move around. If we were looking for it in maybe slope-intercept form or standard form, we would have to move things around. But this one's just point-slope form, so we're done. This one's nice. You're literally just plugging things in. Now what if you were given 2 points? If you're given 2 points and we need to write the equation, the first thing we're going to do is find the slope, which we just learned the formula for, and then we're going to plug that new slope and either one of our 2 points into point-slope form. It doesn't matter which point you use. So let's find our slope first. Slope equals, I'm going to do the first point as x1, y1, and the second point is x2, y2. Again, no reason for that. It doesn't make a difference. You'll get the same thing either way. So y1 or y2 minus y1, we've got -3 minus 7 over x2 minus x1, 3 minus -2. Then -3 minus 7 is -10. And 3 minus -2 is 3 plus 2, which is 5. And this reduces to -2. So that's our slope. Now we can do either point, it doesn't matter which one, and use point-slope form. I'm going to use the first one because I can. So we have y minus our y value equals -2 times x minus our x value. We have substituted everything in, but there's something that we can simplify. That is this minus a negative. Whenever we have this, we don't want to leave that in our equation. We want to rewrite it as x plus 2. Then this is the final form of this equation.